Hello students. Today in this class we will learn about traveling salesman problem. What is traveling salesman problem? Is that suppose there is one traveler who needs to visit uh, all the cities from a list. A list of cities is given, okay, and that traveler needs to visit all the cities from that list, okay, and he has to visit all that cities just once. Okay, so each city should be visited just once. Okay, and the distance between all the cities are known. Okay, so what is the shortest possible route that he visits each city exactly once and returns to the original city? So we have to find the shortest possible route that he visits each city exactly once. Okay, and he must return to the origin city from where he has started. So uh, there are different methods to solve this traveling salesman problem. Okay, so we will do one easiest one, which is also called traveling dynamic programming. Okay, it uses um, a brute force approach. Actually, this approach is called brute force approach. Okay, in this case, we use this dynamic programming to solve this traveling salesman problem, and we will do with an example. Is that clear? So, uh, okay, I will write one example. Suppose there are four cities: A, B, C, and D. Okay, I'll give like this arrow. Okay, that means they are all parallel edges. Okay, that means there is a edge from A to B and B to A, also B to C, C to A. Okay, similarly D to B and B to D also, and finally A to C and C to A also. And I will write the matrix, adjacency matrix. Okay, I will not give the width of the edge in this graph. Instead, I will give in this matrix. Okay, so from A to A it is 0 because there is no loop. Okay, and A to B is 16, A to C is 11, and A to D is 6. B to A is 8, B to B is 0, B to C is 13, B to D is 16, C to A is 4, C to B is 7, C to C is 0, C to D is 9, D to A is 5, D to B is 12, D to C is 2, and D to D is 0. So this is the adjacency matrix of this graph. So we need to find the shortest possible route that a traveler travels through each and every cities exactly once and return back to the um, origin city. So let us suppose that the origin city is A. We'll start from A. Is that clear? Now, uh, okay. Suppose this is the origin city A. You can start from anywhere, B, C, D, your choice. Okay. Now, A can go to B. There's a possibility A can go to C, and also A can go to D. So there are three possibilities for A where A will travel. A can travel to B, A can travel to C, and A can travel to D. Suppose A travels to B, then there are two possibilities, either from B to C or from B to D. Similarly, okay, C can be traveled to B and C also can travel to D. Okay, there are two possibilities. D can travel to B, and D can travel to C. Okay, now if A travels to B, B travels to C, then C travels to only remaining is D. D travels to C, B travels to D, and D travels to B. This B travels to C, and this C travels to B. And now the final thing is this remaining, all this travels to again back to A. We have to travel back to A. Clear? So this is the complete picture of the visits of the traveler to each and every city. So travel can go through A, B, C, D, A, also A, B, D, C, A, C, B, D, A, C, D, B, A, D, B, C, A, D, C, B, A. So this is the, now if there is n number of cities, okay, remember that if there is n number of cities, then there are n minus 1 factorial possibilities. Okay, is that clear? So in this case, since there are 4 cities, so 4 minus 1 is 3 factorial is 6. So 1, 2, 3, 4, 5, 6. So 6 number of possibilities for traveler. Okay, they travel each and every city is exactly once. Now we have to find the shortest route. Now instead of starting from this origin, okay, we will because we have to do each and every, you have to check it out. Is that clear? So instead of, because A to B you have to check each and everything, and finally you'll get the answers. Okay, instead of doing that, we'll start from here. Okay, we'll start from here and we'll do the calculations actually. Okay, now uh, we'll check this matrix. Okay, I've written in my copy also, so I'll directly check from the copy. From D to A, so what was the value from D to A? What was the value given? Okay, if I check over from D to A is 5. Is that clear? D to A is 5. So this is 5. And C to A is, similarly C to A is 4. D to A is 5. B to A is 8. C to A is 4. Okay, and B to A is 8. These are the values that the traveler gets when traveling from this, okay, points. Now next we'll jump over here from C to D, D to C, B to D, D to B, B to C, C to B. Okay, now the traveler has to travel D to, it has already traveled D to A. Now from C to D, so what was the value from C to D? The value from C to D was, it is 9. So already there is 5, so 9 plus 5 is 13, and 9 plus 5 is 14. Clear? And D to C, what is the value from D to C? It is 2. Okay, from D to C is 2. That's why 2 plus 4 is 6. I'll write directly the values. Okay, and again from B to D, B to D is 16. So 16 plus 5 is 21. And D to B, D to B is 12. 12 plus 8 is 20. Okay, and again B to C is 13. 13 plus 4 is 17. And C to B, C to B is 7. 7 plus 8 is, so these are the values that the travelers get. Now for B we'll be having two values because there are two possibilities. Okay, so B to C is 14. Okay, in the side it is 14, and in the side there is 6. Okay, now what is B to C? B to C is 13. Okay, so 13 plus 14 is 1 is 13 plus 14. And what is B to D? B to D is 16. 16 plus 6. This is 27. This is 22. So the minimum is 22. Is that clear? Understood? Okay. Now C to B. C to B is 7. 7 plus 21. Okay. I don't have to write 7 plus 21 and C to D. C to D is 9. C to B is 7. C to D is 9. 9 plus 20 is 29. So this is 28. So minimum is 28 because C to B is 7. 7 plus 21 is 28. Clear? Now D to B. D to B is 12. 12 plus 17 is 29. And D to C. D to C is 2. 2 plus 15 is 17. So this is the minimum. Is that clear? Now the final one. A to B, A to C, A to D. Okay, what is A to B? A to B is 16. 16 plus 22 is, so we have got three values now. 16 plus 22, first one. So A to C, 11. 11 plus 28, and last one, A to D, 6 plus 17. So 20. So this is the minimum. So from the six possibilities, we found that the shortest route is A to D. Okay, from where we got 17, D to C. Yes, D to C. A to D, D to C, C to B, and B to A. Okay, so A to D is 6, D to C is 2, 7, C to B 7, 14, and B to A is 8. Okay, 23. So this is the shortest route. So this is how we do dynamic programming using for this traveling salesman problem. Now we will generate the formula. Okay, how we get this? Okay, we need some algorithm to calculate all these things. Okay, now if we denote this S, uh, S as a okay, before writing S, we'll do for this one. If G denotes the values, okay, uh, that we write for each and every calculation. G of, okay, if I write this I comma, okay, instead of I, in this case we have used, okay, let's, okay, I, okay, G of I of, what is I is the starting vertex, and what is S is the remaining vertex, because from I to I, we can't travel from CTI to CTI. Okay, so S is the remaining vertex. Okay, so G of I comma S, the point value is nothing but minimum. We have to write the minimum always. Okay, minimum of distance from I to J. J can be any one from S. J belongs to S. Okay, so in this case we have got A, B, C, D vertex. Okay, we'll start from A. So I become A. So what is S? S can be B, C, D. S can be anyone, either B, either C, either, okay, this J. So plus, okay, distance from I to J. Okay, now we are going from distance from I to J, plus, now J can be anyone, B, C, D. If we take B, so there are remaining C comma D. Okay, so g of, we'll now find g of for the remaining. Okay, now suppose from a to b. Okay, suppose this j is b, so from a to b, then b, from b, and there the edge goes from b to c and d, so we are at g of from b, in that case b will be the starting vertex, j comma s minus j. Okay, understood? S minus j, so b will be deleted, so remaining will be c and d, s minus j. So you have to find out this. Understood? So this is the formula for this calculations. Okay, remember this formula also. You can also write yourself formula. Okay, just understood that how you're writing the formula. Just try to understand that how you're writing this formula. Okay, so this is the formula. So this is how you solve a traveling salesman problem. Okay, so I'll give you another homework. You just do this one. Okay. Okay. So you will get the weight of age from for each and every age. Okay. So the matrix is like this: 1 2 3 4. Do yourself this one. This is always 0. Okay, and this is 15 10 20, 9 0, 13. Okay, again 12 6 0 5 9 8 8 0. Okay, so I think you can do this one. So try to do. Okay, so try to solve this one and try to find the shortest route. Okay, so this is your homework.